So to recap, in this week, we looked at how we can write code. We looked at development environments, frameworks. Then we looked at how we can share and maintain different code versions using a tool like Git. In this video, we will be looking at debugging. And as we saw earlier, debugging is a very important task which a software developer does. So let's look at some key terms which are used in debugging. So one important term is the word error, the term error. So what is an error? So error is nothing but a discrepancy between the actual behavior and the intended behavior. So as a developer, you have an intended behavior based on the specifications or the requirements. But as you run your program, you realize that there is a deviation from this intended behavior. So this discrepancy is known as an error. And now when this error is observable, right, in terms of, let's say, an incorrect output value or an exception, now that is known as a failure. And now what is a fault? A fault is nothing but the line of code where this failure or this observable error has occurred. And that is known as a fault. So then what is debugging? So debugging is nothing but determining the cause of this failure and rectifying your code so that this failure goes away. So what are the different steps in debugging? Well, these are the broad steps and it is quite intuitive and obvious, right? So in order to debug a fault, we have to first reproduce a problem, right? Reproduce, or for a particular input, maybe the program is deviating from the intended behavior. So reproduce a problem, maybe specify an input for which this error occurs. Find the cause of this defect. You investigate the fix. So you come up with a fix and you implement it and you test whether the error is going away or not, right? And these are obvious steps one does in debugging. So in this video, we will be focusing on how we can find the cause of a particular defect. So let's reflect on this question for a moment. So I'm sure most of you have written programs and you would have encountered errors or defects as you run your programs, right? So can you think of some techniques which you have used to debug a defect? How do you actually go about debugging a defect? You can pause this video and think about how you debug a defect before proceeding. So now let's look at some techniques for debugging, right? So one way to debug is to insert a lot of print statements in between lines of code, right? And this is known as logging. And I'm sure this is a practice which most of you do, right? If there is some unexpected output or some errors, you insert some print statements at strategic locations and examine the output. And this gives us an idea about where our code is going wrong. Another way is to use dump and diff, where you use a diff tool. A diff tool gives you the difference between two output files, and you can use this to compare logging data between a correct execution and an incorrect execution. Another important technique is to use a debugger and use the stepping in function in a debugger. We will look at this in more detail in this video. And another technique is to use a tool which is known as a profiling tool. So profiling tools, they give us statistics about how often or how long various parts of a program are executed. So developers use such profiling tools also in their debugging process. So these are different techniques which we can use for debugging. And now we will look at what strategies we can use while debugging a program. So one common strategy is manipulating the input, right? So we have a program which is not giving the desired output for certain inputs, right? So we provide an input and we observe differences in output, and based on this set of inputs and outputs, we try to determine what the error or fault is in the program. And this is a common technique which we use, right? So let's take an example. So the program on the right is a simple program which calculates the first n primes. So it takes n as an argument and it returns a list of the first n primes. However, there is a logical error in this program. So learners, I want you to go through this program and try to determine what the logical error is. You can pause the video here and think of what the error is before proceeding. So now let's look at how we can use the input manipulation strategy. So here is the program and I try giving a set of inputs, right? So I run this program and I start with 2. And for this input, it is giving me the correct output, 2, 3, right? Which is the first 2 prime numbers. Now when I type in 3, I'm still getting the same output, 2, 3. Instead, it should have been 2, 3, 5. Now, if I try it for 4, again, it's giving me only 3 prime numbers, the first 3 prime numbers. For 5, again, just 3 prime numbers. And for 6, it's giving me 4 prime numbers. So what all can we infer from these set of inputs and outputs? So one thing is that the logic, so it is printing prime numbers only, right? So it is giving the set of prime numbers, but the error is, or the logical error is in the number of prime numbers which it is giving, right? So instead of 6, it is giving me 4. Instead of 5, it is giving me 3. So based on this, now I look at the program and look at the variable or the logic which determines how many numbers should be there in the n primes list. right? And I realize that variable I is the variable which counts the number of elements in the list, right, in the n primes list. And if you have noticed, we have to increment I only if the number is prime, right? Whereas here we are incrementing it outside the if condition. So that was the error. Now if I put the increment in the if condition, and now if I try running it, let's take say 3 and 4, 5, right? So now it is giving the correct output. So now what did we do in this strategy? We just gave us a different set of inputs. We looked at the outputs and then we tried to determine what the error is. So this is a strategy which you can use while you debug a given program. So the first strategy which we saw was input manipulation, right? So we give a set of inputs, observe the differences in output, and try to see what the fault or the error is. Another strategy for debugging is known as the backwards debugging strategy. And here what we do is, in a given program, we find the statement that generated the incorrect output. It can be a syntax error or some other error, and we follow data and control dependencies backwards, right, to find the incorrect line of code, right? So we look at the statement which has the incorrect output, and then we go back and see which all data and control dependencies are there, and then we look at the incorrect line of code. So let's look at the same first n primes program itself, right? So this is the code for that, and I've made another change to this code, right? And now when I run this program, let's say I gave the number 5, I realize that my program is not terminating, right? And now I can use the backward strategy to see what is the error, right? So based on this, what I can realize, or what we realize, is that this while is not terminating, right? And this while is not terminating because the reason being I is never greater than or equal to n, right? So if we look at the code, we realize that I is incremented at this place, right? And for I to be incremented, so now I start working backwards. So I realize the error is that, or the logical error can be that I is not getting incremented, and now I start working backwards, right? And I see why is I not getting incremented. The reason being prime flag is not true, right? And however, I see that prime flag has been set to true here, right? But what we now realize is that if the number is not prime, that is, if it is divisible by some other number, then we are setting prime flag to false, right? And after this loop, we are not setting prime flag back to true, right? And that's the reason why I is not getting incremented, and hence this loop is not terminating, right? So this prime flag being set to true should be at the start of every iteration of the while loop. right? And now if I try running this code, right, the program is terminating and giving the correct output, right? So what did I do in this backward strategy? I examined the line of code which has the error, right? And I worked backwards. I went to the previous lines and tried to see how the data and the control is changing. And then I deduced what the error was. So that was the backward strategy. Now, the inverse of that is the forward strategy, right? You find the event that triggered the incorrect behavior and you follow control flow, right, in the forward direction until the incorrect state is reached. So this is the inverse of what we did earlier, right? For the same program, now what I do is I start from the beginning and mentally start tracing, what are the values of the variables, and I go through each iteration of the loop, and then I can come to the same conclusion, right, as the backward strategy, and I realize that prime flag initially was here. It has to be brought here because prime flag, once it's set to false, it's not becoming true again. So that's what the forward strategy is. And finally, there is another strategy known as black box debugging, right? And this has to do whenever we work with APIs or libraries from other sources, right? So we look at documentation, we look at code examples to understand what is the correct usage of that API. We do not have access to the inner workings of those libraries and APIs, but by going through the documentation and code, we are able to understand if we have made certain errors or mistakes while calling an API or a library. So these are different strategies which you can do as you debug your code. Now that we have seen what these different strategies are, now let's look at how we can use a debugger to debug our code. And in this video, we will be looking at how we can use PDB, which is the Python debugger. So this is the code for calculating the first 10 primes, which we saw earlier. And there is an error in my code here. I have placed prime flag equal to true above the while loop and not inside, right? And now if I run this code, right, the while loop won't terminate, right? Now in order to use PDB, you have to install it using the pip command, right? Pip install PDB. And since I already have it, I'm not going to install it again. And you can call the debugger by specifying or calling the module PDB and the file, right? And now you see that what the debugger does is it pauses execution and allows you to step in or move execution line by line, right? So currently you can see that execution is paused at line number 7, right, which is the definition of the first 10 primes, and it allows you to execute each line of your code, right? If you want to exit the debugger, you can do Control Z, right? Another way to invoke the debugger is to write code itself, right? So you can import the PDB module and you can just call the function pdb.setTrace, right? And now you have to just run the first 10 primes Python file, and you can see that execution is paused here, right? So it tells me now currently I am the next line which the debugger will execute is this, right? And now in order to execute or move to the next line, I can use the option called N, right? I type in N and press enter, right? It will go to this line, and now if I enter 3, right? Now it's telling me that I am in line 28 and the next line of execution is this, right? First n primes. Now if I press N again, now I can see that it has gone into first n primes and it's executing the first n primes function. But this is not very useful, right? I really want to know what's happening inside the first n primes function. So what I'll do is I will exit and I will run this again. And now when I enter a number, and what I will now do is use the option called S, which will step into the first n primes function, right? And now you can see that the next line which will be executed is line number 7, which is the first n primes method, right? So now I can press N and now I have entered the first n primes function, right? Again can go N. So now I've come to line number 9, right? The next line to be executed is line number 9, right? So currently I am on line number, now the next line to be executed is line number 10, right? So using the N and the S command, I can move to the next line as well as step into particular functions, right? Now let's say I want to know the current value of a variable, a list, etc. So I can use the P option, right? So here let's say I want to know what is the value of I. So I type in P and let's say I, and it gives me the output 0, right? So we have just initialized I to 0, right? And you can type in all sorts of expressions, right? So let's say I comma prime flag comma num, right? Something like this. I num and prime flag, right? I can create a list of variables, expressions. Okay, so the next line to be executed is prime flag. So I haven't initialized prime flag equal to true yet. That's why it's giving this error. So I click, I move to the next line, right? And now if I try to execute this expression, right, I get I is 0, num is 2, right? And prime flag has been initialized to true, right? And now I can keep on executing the code and check what is happening. So now the control is currently here. So prime flag, as we saw, was true. So it will enter into this if condition and I press N, right? I gets incremented. Now if I want to see what is my n primes list, it is 2, right? So using the N command, N and S and P, I can, get the different values of a variable at the current state, right? So another way in which we can use the debugger is to set up breakpoints, right? Now, if you have noticed, it is getting a little problematic here because I need to continuously press the N button, right? I have to type in N to get each and every line. But oftentimes I just want to know what are the values of variables, for example, at a particular line, right? I'm not interested in stepping through each line in the program. I just want to know the values of variables at particular strategic locations in my code, right? So here, for example, I want to check when prime flag is becoming true, right? So one way to do this is to set up what is known as a breakpoint in line number 17, right? So debugger allows you to set up breakpoints. And what I'll do is again run the debugger, and I use the option B to tell the debugger to set up a breakpoint, right? This is my file first and primes. Set up a breakpoint at, let's say, line number 17. So when I press enter, so now the debugger says breakpoint 1 has been set up at line number 17, right? Now I can use the N to move to the next line, right? But now I can use the C option, which is continue, which tells me continue, or which tells the debugger to continue execution of the program until you reach the breakpoint. So now when I type in C and press enter, you can see that the control has directly come to line number 17, right? And now at line number 17, I can examine what the values of, let's say, I, num, and prime flag is, right? Okay, I is 0, num is 2, prime flag is true. So now since prime flag is true, when I press N, it should go to line number 18. Yes, it is appending the prime number into the n primes list, right? And it's incrementing I. Now again, I can press the C option, and again, now the control goes to, the execution happens and the control stops again at line number 17. And here now again, I can examine what I and num is. Yes, num is 3, so 3 should also be included in the num primes list. That's what is happening, right? So till now, I don't see any errors in my code. Now again, I press C, and now control has execution has resumed. Now if I see what the values are, yes. So when num is 4, right, my prime flag is false, right, and it should not enter the if condition, if block. Let's see if that is what is happening. Yes, right. Now on continuing the execution, now when I look at the values, I realize that num is 5 and num is a prime number, but my prime flag has been set to false, right? And 5 should have been included in the num primes list, but it's not happening, right? So now if I press N, right, it's not entering the if condition, num is getting incremented, right? And now if I look at, if I want to see what is n primes list, I realize that 5 is not getting included in the list, right? So this is the way in which you can use a debugger to step into or trace the execution at each line of your code, set up breakpoints, and examine the values of variables. So to summarize, this is what we saw in the PDB, which is a Python debugger. You can invoke the debugger by importing the PDB module and calling the setTrace function. We looked at various options like executing the next line, stepping into a function. We can find out the values of variables at a particular line using the P option. And we saw that we can set up breakpoints also and use the C option to continue execution till that breakpoint.